Hello everyone. So in this video we are going to discuss the sixth problem which came in BMath BStat 2022. So the problem is here. So consider a sequence of points P1, P2 and so on in the plane such that the first 3 points are given, that is P1, P2, P3 are non-collinear. So that means you can draw a triangle. And for every n greater than equals to 4, Pn is the midpoint of the line segment joining Pn-2 and Pn-3. Okay. Now you have to basically prove that the area of the triangle formed by Pn, Pn-1, Pn-2 converges to 0 as n goes to infinity. Okay. So now for this, many students have done that. They have just drawn the first triangle and then the second triangle, and from there they showed that the area is getting halved, and thus they have just written that the nth triangle will be the area of the first triangle multiplied by 1 by 2 to the power n minus 1. Okay, or so directly writing that won't fetch you the full marks, because I mean there would be question mark how you are getting that, like it's happening for the first two or the first three or whatever, doesn't mean that it will happen for all. So maybe you can use induction or something. So let's proceed. So suppose we have those 3 points P1, P2, P3. So let's have a triangle. So okay, so let's name the points. So suppose this is P1, this is P2 and this is P3, and then P4 will be the midpoint of P1 and P2. So here we have P4. Now let's join P4 and P3. Okay, and then we will be having the midpoint of P2 and P3. So here let's have the midpoint P2 and P3, which is P5. Let's again join. Okay, so what is actually happening is, if you notice that the first triangle, which is triangle P1, P2, P3. So let's write it of the form that is given in part A: P3, P2, P1. Then the second triangle is nothing but this P4, P3, P2, which is nothing but, you can show that since P4 is the midpoint, so the area will be getting halved. Okay, so I mean basically you are getting two triangles having the same base length and the same height, and so the whole triangle is getting divided into half. Okay, I'm not writing that you have to write that explanation. So that is so that means half of this, the area of this triangle is equal to the area of triangle P4, P3, P2. Okay, now so that means we are having the first triangle, and then the second triangle is nothing but the area is getting halved. Okay, now let's talk about the nth step, or let's talk about the n minus 2th triangle, that is Pn, Pn-1, Pn-2. Okay, so this triangle, so if you're having this triangle, so this is basically the n minus 2th triangle. So because here you can see first triangle, second triangle, n minus 2th triangle. Okay, so now from here I have to just show that the n minus 1th triangle will have area half of this triangle. Okay, so how do I do that? I'll just basically draw another triangle where I have those points. So I'm having P n minus 2, P n minus 1. Okay, so this is the triangle I'm having, and now by definition I know that Pn plus 1 will be the midpoint of this Pn minus 2 and Pn minus 1, and thus when I join Pn and Pn plus 1, so I get the area of the next triangle, that is, again you can just same base length, same height, and so the area of the next triangle is basically getting half of this. So half of this area is the area of the next triangle, that is this P n plus 1, Pn and Pn minus 1. Okay, and so that means now by induction you can always get, like, at any step, wherever you have this triangle, and the next triangle will be half of the area of the previous triangle. Okay, and thus what we can say is that the area of the nth triangle, so you can see that the area of the second triangle is half of the first triangle. Okay, then the area of the fourth, so you can like go backwards, like half, so the area of the nth triangle will be half of the area of the n minus 1th triangle. Okay, and so on and so forth, like you can just go backward, or half into, now the area of this n minus 1th triangle is again half of the area of the n minus 2th triangle, and so on and so forth. Okay, so finally this will boil down to, so you see that for n minus 2 it's 1 by 2 square. Okay, so try to view the pattern. So at the very end, what will it be? So it will be the first triangle, right? So that means you will be having n minus 1. Okay, so that means it will be 1 by 2 to the power n minus 1 times the area of the first triangle, and that is nothing but that was given to us, that is the triangle P3, P2, P1. So area of the triangle P3, P2, P1. Okay, and thus this goes to 0 as n tends to infinity. Okay, as simple as that, and we are done. So don't directly write down that it's working for the two triangles and you directly write down the formula, so that won't be accepted. Okay, you have to prove that in general it's happening. So okay, now there is something more, that is, let L denote the line segment joining P1 and P5. Now you have to prove that the point P9 lies on L. Okay, so okay, let's draw the diagram. So I'll be rubbing this out. So for this I'll be using the MENELAUS theorem. Okay, so if you in MENELAUS theorem you can use direction, or you can go without direction. So without direction, the product of the ratios would be 1. Okay, and I'll be using that. So fine. Now let's take further. So this is P5. Now P6 will be the midpoint here. So almost around here. P6. Let's join P5 and P6. Then okay, so the next midpoint would be P7, which is here, which almost here, P7. So again, let's join P6 and P7. Okay, and then the next one will be P8, which will be the midpoint here. Again, let's join. Okay, and P9 will be nothing but it will be the midpoint of P7 and P6. Okay, but okay, let's now take the line L. So this is the line L. Okay, now let's mark this point where this let's mark this point as X, where the line L and P4 and P3 are intersecting. And also okay, so I'll mark that point where P7 and P6 and the line L are intersecting. I'll mark that as suppose P9 dash. Okay, so let's say that it's P9 dash. Okay, so I'll just finally prove that P9 dash is equals to P9. Okay, so now first what I'll do, as I told, I'll use MENELAUS theorem. So that means I need a triangle and a transversal. So first the triangle would be triangle P2, P3, P4, and transversal would be P1, P5. P1, P5 as transversal. So then what are we getting? We are getting the ratio to be, just start from any point. Suppose we are starting from P4. So P4 by X, the point X, divided by X P3, okay, times then P3, P5, P5, P2 times P2, P4 times, sorry, not P2, P4. So the transversal is cutting this side at P1. So P2, P1 divided by P1, P4. Okay, and this is 1. So you would have seen -1 in where you have studied MENELAUS theorem, but that is minus sign comes due to direction. So I am not considering direction here. I am only worried about the ratios. Okay, so we know P4 is the midpoint. So that means P1, P4 will be double the length of P2 sorry, P1, yes, P2 P1 will be double the length of P1 P4. So this is 2. What about this P3 P5 and P5 P2? This is 1, and this is P4x by x P3, which is equals to 1, and thus we get P4 x by x P3 as half. Okay, fine. P4x by x P3, we are getting it as half. Now my idea is to get the ratio of P4x and x P6. Okay, because I know that P4 P6, okay, so P4 P6 is equal to P6 P3, and let it be equal to R. Okay, so for some positive real number R. So then I just want to get to that ratio. So here if you notice that, okay, let's reverse it. So I get x P3 by P4 x is equals to 2. Okay, I need not do that. Okay, let's see. So look at x P3, that is R plus x P6, and look at P4 x, that is R minus x P6, and this is equals to 2. Correct? Now just multiply it, so cross multiply it, and you would be getting, so just check it out. So you would be, so I have already done the calculation, so that would be coming out as, so okay, let's do the calculation. So R plus x P6 is equals to R 2 times R minus 2 times x P6. Okay, and so you are getting R as 3 times x P6. Okay, and R is what? R is nothing but, here as you can see, P4x plus x P6. Okay, so P4x plus x P6 is equals to 3x P6. So P4x is equals to 2x P6. Okay, and so we get the ratio of P4x by x P6 to be equals to 2. So we got the ratio of P4x and x P6. Okay, now why did I take that out? Because the next MENELAUS theorem that I am going to use in whichever triangle and the transversal, I needed that. Okay, so that was back calculation. Okay, that is, I need this, and that's why I derived this. Okay, so now the next thing is, I'm going to take the triangle, let's say here, I'm going to take the triangle P4, P6 and P7. Okay, so here is the triangle P4, P6, so P4, P6 and P7. This triangle I'm going to take, because I'm going to prove that P6 P9 dash and P9 dash P7, that ratio is equal to 1. And if I am done, then I am proving that P9 dash is the midpoint. Okay, and that is equals to P9. So I'll be using triangle P4 P6 P7 and transversal as let's say transversal, I'll use it as P5x. Okay, so let me write it down somewhere here so that you get to see the figure. So triangle P4, P6, P7 and transversal as P5x. Okay. So now when this transversal is there, P5x, so let's go for the MENELAUS theorem. So I have P4x divided by x P6, okay, is times then P6 P9 dash P9 dash P9 dash P7, okay. And then you see that in that triangle the transversal is cutting the the side P4 P7 at P5. So the next ratio would be from P7 you have to go to P5. So P7 P5 divided by P5 P4, which is equals to -1. Okay. And okay, so then the next thing is P4 P6 Px P, okay, P4x by x P6, that is equal to 2. Okay. And let's see, times, then let's keep this P6 P9 dash divided by P9 dash P7 times this ratio. As you can see, P7 is the midpoint, so P7 P5 will be so P5 P4 will be double the length of P7 P5, so that means this ratio is half, and so it's equal to 1 here. So this is getting cancelled out, and that proves P9 dash is the midpoint of P7 P6, and thus P9 dash is equals to P9, the point P9. Okay, and it lies on the line L thus. Okay, so and hence we have, proved. And yes, I have written it like this. You don't have to write it like this because the figure would not be viewable. So that's the proof using MENELAUS theorem. And yes, and the first part was done by induction. So I hope you liked the video. Thanks for watching. See you in the next one.